Welcome back to the video. Today I'm going to be covering my Chapter 2 notes from our operating systems class. So the first thing we're talking about is the operating system services. So the user interface, it includes like a GUI with windows, a keyboard, a mouse for input, a keyboard and mouse for input, and it's sometimes using a CLI, which is a command line interface. So program execution, the OS must load programs into memory, and then it runs the program, and it can also end the program. IO operations, the OS manages IO, it's pretty simple. File system manipulation, the OS has to allow programs to read, write files and directories, create and delete files by name. So it's pretty, we kind of talked about it. It's pretty self-explanatory. Communication. An OS implements shared, oh, this is pretty important. Remember, shared memory is where two or more processes read and write to a shared section of memory. A message passing is packets of info are moved between processes. That's really important. Error detection. This is where the OS fixes errors and also detects them. It can terminate error causing processes and returns an error code or halts the system. Resource allocation. The OS is in charge of deciding who gets resources. That includes CPU cycles, main memory, and file storage. So logging. This keeps track of programs and records what computer resources they use. Protection security. The OS has to make sure that access to the system resources are controlled and make sure that users authenticate themselves before granting access and make sure IO devices don't make invalid access attempts. Pretty self-explanatory. Chapter 2.2 talks about user and OS interfaces. So once again, the CLI we kind of mentioned is the command line interface, or it could be also be the command interpreter. Users enter commands to be performed by the OS. Shells. When a system has multiple command interpreters, it could include the C shell, the bash shell, or the corn shell. And there are two ways for the command interpreter to do something. The first one is the command interpreter has a code to execute, and the second one, it doesn't understand the command, it's just used to find a file and then execute it. The GUI, the first one was Xerox Alta Computers in 1973. It's not really useful, but it's just like a fun fact. A system call provides an interface to the services made available by an OS. It's pretty much asking the OS to do something. An API, it's a specify the set of functions available to an application programmer. Runtime environment, all the software needed to execute app written in a given programming language. This could include the compiler, interpreter, libraries, and loaders. Compilers interpret is pretty good to know. So C and C++ are compiled into machine code and then ran. Interpreted languages are they're interpreted and they're translated line by line into machine code and then they run or execute. This could include Python or JavaScript. Remember, Python, JavaScript, Ruby interpreted. It goes line by line to machine code and then runs. C or C++, they're compiled to machine code all at once and ran. That's why they're like faster. The system call interface, the link to system calls made available by the OS intercepts calls from the API and calls the correct system call in the OS. And here we have some types of system call. The process control, it creates and ends processes, loads, executes, gets set process attributes, and then wait and signal events. File management, create, deletes files, open, closes them, rewrite, reposition, get, set file attributes. Device management, request, releases device, read, write, repositions, and then get, set device attributes. Logically attach or detach devices. Information maintenance, get set time or date, get set system data, and then get set process file or device attributes. Communications, create, delete communication connections, send, receive messages, transfer status, info, attach or detach remote devices. Protection, get set file permissions, and the bootloader. It locates a piece of software, then loads it into memory and then executes it. Process communication, message passing, and shared memory. Once again, pretty important. System services, aka system utilities, provides a convenient environment for program development and execution. Some are user interfaces to system calls. The registry is used to store and retrieve config info. Daemons, services, or subsystems are constantly running system programs or processes. Relocatable object file. Files designed to be loaded into a physical memory location. The linker combines relocatable object files into a single binary executable file, and the loader loads that binary executable file into memory where it can be run on a CPU core. Relocation assigns the final address to a program part and adjusts codes and data. The ELF executable and linkable format. When we talk about the entry point, the location of the first instruction where the program executes, and this is the reason why some apps are OS specific. And then an app can run on multiple OSs in three ways. The app can be written in an interpreted language such as Python or JavaScript, and then we can use that interpreter to run that code on many operating systems. Two, the app can be written in a language with the virtual machine such as Java. that runs a virtual machine that runs the app. The virtual machine is a part of the runtime environment. And then three, the app developers can use a standard language or API where the compiler generates binaries into machine and OS specific languages. ABI, the application binary interface, I don't think we really talk about this. It's easy to find how different components of binary code can interface for a given OS on a given architecture. An ABI is the architecture equivalent to an API. OS system design, what do we talk about? This mechanism for policies is kind of important. Mechanism is how something will be done. Policy is what will be done. OS system structure. This is kind of important right here. We do talk about this further in another chapter. So monolithic, it places all the kernel functionality to a single static binary file, and it runs in a single address space. So this is a monolithic operating system like structure. The kernel provides the file system, CPU scheduling, and memory management through system calls. Tightly coupled is like it would be an example would be the monolithic one where one change can affect the whole system because it's all placed together. Loosely coupled is going to be divided into separate smaller components, and then changes to one thing might not break everything. Remember, monolithic is part of the system structure we have to remember, and then the layered one is like the operating system is divided into layers. It's like more secure. And I think layer zero is the hardware. It's the highest layer is the user interface. So it's dividing into layers. Layer zero is the hardware, and the highest layer is the user interface. And then you can communicate through layers. Remember, monolithic, layered, and then microkernel. It removes non-essential components from the kernel and implements them as user-level programs that reside on separate address space. That's another operating system structure. And then what else? Modules are loadable kernel modules. Kernel has a set of core components and can link additional services later. Kernel environment, I don't think we really talk about this too much. Booting, starting a computer by loading the kernel, that's kind of important. How system boots, so the bootstrap or bootloader locates the kernel. The kernel is loaded in memory and started, and the kernel initializes the hardware, and the root file system is mounted. Pretty important. Core dump, capture of memory process crash. It's going to be a failure in the kernel. Counters keep track of system activities. The system calls and the system call counter. Tracing collects data from a specific event. And the BCC or the BPF compiler collection, the toolkit that provides tracing features for Linux. And in here we talk about the lecture. I can make another video if you guys are interested in the lecture. Well, if this helped in any way, please leave a like and subscribe.